Good morning class. In last class you learned about what is differentiation and how its basic formulas are used in solving physics numericals. Okay. In this class we will learn about what is integration, what is its use and why it is necessary in physics. And we will learn about some basic formulas which will help you to solve the numericals in physics. Okay. So before starting integration, let us understand why it is necessary. Suppose you have been given an equation for displacement that is denoted by S equals to t square plus 4t, and you have been asked to find the instantaneous velocity of this equation. So you can easily find out that you know the formula for instantaneous velocity is the rate of change of displacement with respect to time. Okay. So you can find easily t square plus 4t equals to 2t plus 4. Clear? So you got the instantaneous velocity from the equation of displacement by using the formula of differentiation. But if you have been given with velocity v equals to 2t plus 4 and I have asked you to find the displacement. So how will you find the value of displacement from the given equation of velocity? In this, differentiation formula cannot be used. In this, the process of integration and the basic formula of integration comes into use. Okay? In this, we will try to find out the value of displacement with velocity by the process of integration or by the method of integration. So from this, you have got an idea that integration is nothing but it is the reverse process of differentiation. Integration, it is a reverse method of differentiation of a function. Clear? And it is denoted by a symbol like this. Okay? This is the symbol of integration and it is the reverse method of differentiation. Clear? Now we will see what is the use of integration. Okay, now let's see what is the use of integration. Consider a graph y versus x graph. Okay, this is y axis, this is x axis. X and y are some quantities, and I have asked, this is the origin, and I have asked to find the area under this graph. So you can easily find with respect to axis x. So you can easily find the area of this triangle using the area of triangle formula. And if I am asked to find the area of this graph with respect to x-axis, so again you can find the area of this rectangle, that is length into breadth. But what if I asked you to find the area of this graph? Okay, this is a curved type graph and I have asked you to find the area of this graph. In this, what will you do? Consider, this is x, consider a small part of x, that is dx. Clear? The small part of this axis is dx. And I have to find and draw a rectangle which is of length y1 on the y-axis. Clear? Now you can find the area of this strip. That is, it is a form of a triangle, rectangle. See, it is a rectangle. So you can find the area of the strip. Strip is like this, of length y1 and breadth how much? dx. So you can find area as length into breadth. Clear? If I asked you to find the area of this curve and you took another strip like this, this is also a of breadth dx and length, suppose y2. Clear? So you can also find the area of this strip as y2 dx. Okay? So now if I cut this graph in small strips like this, each of breadth ds and varying length, so the total area required can be the sum of each area of these strips, that is y1 dx plus y2 dx plus y3 dx plus net total yn dx. Suppose I took it as yn and this is the n dx. Okay, so the total sum can be written as summation of yn dx, where I do write it as n from the value 1 to n. Clear? Yn dx. This is the total area of this curve. But in this, you know, it does not give the perfect answer or perfect area of this curve. Why? Because you can see in this curve we are left with this area. Similarly, this area, it is just like this. It's not a perfect rectangle. We are left with this area. So to remove this problem, what will we do? We will substitute the summation with the symbol integration, that is y dx. This will give us the total area of the curve, okay, under xy graph. Okay, this will give the total area of the curve from origin to this point. Okay, so integration will take all the continuous varying function, but in summation we were left with this parts which was substituted and made up by this integration. So integration is basically, it is the method to sum of the effect of continuous varying function. What is continuous varying function? Continuous varying function. It is the method of sum of the effect of continuous varying function. But in summation, it is the sum of the discrete values, but integration is the sum of the continuous values to give the total effect of the curve. In this extra area were not calculated in a summation form, but in integration we get the sum of the effect of continuous varying function. We get the total area of the curve using integration. If I wish to find the area from origin to this, suppose from here to here, so we could write easily from x0 to x-axis. Suppose this is x2. We got the limit from 0 to x2. If I wish to find the area from this x1 to x3, so I could write it as y dx from x1 to x3. By giving proper limit, we can find the area and we can find the total effect of the continuous varying function. So basically, integration is the method of addition of small changes to create a big change. Okay, so integration is the reverse process of differentiation and it is denoted by a symbol this, and instead of summation we use the symbol integration to calculate the sum of the continuous varying function, but in summation it is the sum of continuous, it is the sum of discrete values of function. Clear? Now we will see some basic formulas which will be very important in calculating the numericals of physics. Okay, so one by one we will see the formulas and do each examples. Now the formula of integration. The first formula goes like this. Integration of x to the power n dx. We have to integrate x to the power n with respect to dx. It goes like this. X n plus 1 by n plus 1. Power को add करो, divided by addition of that power plus 1. Okay. लेकिन provided plus c. Provided n should not be equals to minus 1. क्यों? Because minus 1 plus 1 क्या हो जाएगा? 0. एंड डिनोमिनेटर में 0 मतलब हम उस फंक्शन को डिफाइन नहीं कर सकते, इसलिए n का वैल्यू कभी भी -1 नहीं होना चाहिए. एंड हियर c इज इंटीग्रल कांस्टेंट. इंटीग्रल कांस्टेंट बोलो या इंटीग्रेशन कांस्टेंट बोलो. ओके, दिस इज नोन एज इंटीग्रल कांस्टेंट और इंटीग्रेशन कांस्टेंट. तो ये c लगा क्यों? c जब मैंने इंटीग्रेशन किया x टू द पावर n dx को, मैंने ये मेंशन नहीं किया कि मुझे इंटीग्रेट कहाँ से कहाँ तक वैल्यू तक करना होगा. आई डिडंट प्रोवाइड द लिमिट कि मुझे 1 से 2 करना है कि 3 से 4 करना है कि या a से b ही करना है. जब हम प्रोवाइड नहीं करते कि इंटीग्रेशन कहाँ से कहाँ तक करना पड़ता है, देन वी विल पुट द कांस्टेंट c. दिस टाइप ऑफ इंटीग्रेशन इज नोन एज इनडिफिनाइट इंटीग्रल. ओके, दिस इज एन एग्जांपल ऑफ indefinite integral where constant c is supposed to be used. Clear? Whenever we are not provided with the integration from where to where, that type of integration is known as integral constant. And after solving that integration, we should provide a constant c. That type of integration is known as indefinite integral. So you got the first formula. Integration of x to the power n dx equals to x n plus 1 divided by n plus 1 plus c. c is the integral constant or integration constant. Let us see one more example. One example of this. You are given with x to the power 3 dx. See, this is the power n and it is not equals to -1, so you can easily find it as x extra. The power gets added by 1, 3 plus 1 divided by 3 plus 1 equals to x to the power 4 by 4 plus c. This is the answer. Okay. One more example. X integration of root over of x dx. Root over of x dx. We know root over means x to the power half लिख सकते हैं. Clear? So it is equals to x half plus 1 divided by half plus 1. That is equals to x to the power 3 by 2 and it is 3 then 2 plus c. Clear? These are the some examples of regarding first formula. So please note it down and we will proceed towards the second formula. The second formula is integration of dx. Okay? Just integration of dx. तो हम इसको ऐसा लिख सकते हैं ना, x to the power 0 dx. Clear? x to the किसी का भी power 0 हो तो वैल्यू क्या होता है? 1. So we can write it as, by using the first formula, we can write it as x 0 plus 1 by 0 plus 1 equals to x plus c. Clear? So here we got the integration of dx is x plus c. कभी भी इंटीग्रेशन ऑफ dx आए तो सीधा क्या लिखना? x plus c, इसीलिए क्योंकि ये indefinite integral है. Clear? This is the second example, second formula of integration. Okay? Whenever you are provided with, find the integration of dt. Simply write it as t plus c. where c is the integral constant. Okay, dt is another function. Now let's move on to our third formula. Integration of x to the power minus 1 dx. x to the power minus 1 dx. यहाँ हम फर्स्ट फॉर्मूला नहीं डाल सकते क्योंकि यहाँ पे पावर क्या है -1. So this will go like this. I can write it like this ना, dx by x or 1 by x dx. So 1 by x dx equals to log base x plus c. If you have remember, the differentiation of log base ex with respect to dx is 1 by x. Similarly here, the integration of 1 by x dx is log base ex plus c. The differentiation of log base ex is 1 by x. Integration of 1 by x dx is log base ex. So here you can see that now integration is the reverse process of differentiation. Clear? Now let's move on to our fourth formula. The fourth formula is integration of c x to the power n dx, where c is a constant. So the answer of this is, if c is a constant, just take it out, and the remaining is, you know, integration of x to the power n dx equals to c x to the power n plus 1 by n plus 1. Clear? For example, if you have been given the question 5 x to the power 4 dx integrated. So we know that according to Yale's formula, this is 5 x power is 4. 4 plus 1 divided by 4 plus 1. That is equals to 5 x to the power 5 by 4 plus 1 is 5. 5 cancel. That is x to the power 5 plus c. C is used as integral constant. So this is the fourth formula. If a constant is multiplied to x and dx, then you can just take out the constant and integrate the x and dx by using the first formula. This is some example. One more example is integration of 1 by 3 x to the power 2 dx. Clear? So simple, 1 by 3 take it out, and x square 2 plus 1 by 2 plus 1, that is 1 by 3 x cube by 3, that is 3 is multiplied here, x cube by 9 plus c. Clear? So note it down and we will move towards the fifth formula. The fifth formula is integration of u plus or minus v dx. Plus or minus indicates that if u and v are added, otherwise u minus v dx, where u and v are functions of x. There, in this, just what you have to do, separate it. U dx plus or minus integration of v dx. That is integration of the first function, addition or subtraction, integration of second function. Let us understand it by one example. If you have been given with a question, integrate x square plus 2x. Clear? Dx. You have to integrate it. See, these are the two functions which are being added. So, simply write it down, x square dx using this formula plus integration of 2x dx. Now you can individually solve these integrations. You know, x square dx, the power is there. So, 2 plus 1 by 2 plus 1 plus integration of 2x dx. 2 is a constant, take it out. And x power is 1. 1 plus 1 equals to x cube by 3 plus 2 into x square by 2, 2 cancel, or it is x cube by 3 plus x square plus c. C is the integration constant. Do you understand how it came? Just take the integration, separate the integration of first function, then second function. If subtraction was given, then you can easily put the subtraction sign, and this is the answer. Okay. Now, if more than 2 or 3 functions are given and they are added or subtracted, you can use this formula. Clear? Now, let's move on to the 6th example. Now, the 5th formula is integration of c u dx, where c is a constant and u is a function of x. U is a function of x. Very simple, nothing to do. This, take out the constant c, integration of dx. Okay? Example, if you are given with 5t dt dx, where t is a function of dx. So what you have to do, take out 5, remaining is t dx. Clear? It's just an extra formula in integration. What you have to do, the constant should be taken out of the integration and the remaining will be inside the integration. Clear? Now, let's move on to the 6th example formula. If you have been given integration of e to the power x dx, you know the differentiation of e to the power x with respect to x is the same e to the power x. Similarly, the integration of e to the power x dx is e to the power x. Clear? Anything if given in the form of integration of e to the power x dx, it is simple as e to the power x. Okay? Now, a new concept in integration comes, is finite integral. If a function is integrated within limits from a to b, that is, let the function is fx, okay, and it is integrated from limit a to b with respect to dx. It is integrated from limit a to b. Then we get the answer f of x. If the answer is f of x, capital F of x, from a to b, limit provided is a to b. So what you have to do, substitute the value of x as the limit, upper limit minus lower limit. Clear? This can be well explained with an example. If the integration of a function, okay, within the limit from, let us from a to b, then the answer, if it is capital Fx from a to b, then the answer will be f of b upper limit minus f of a. For example, if you have been asked to solve x to the power 3 dx from 1 to 2, very easy. So this is the function. First integrate it and then puts the limit. So it will go like this. You know the integration of x cube is x 3 plus 1 by 3 plus 1, and the limit are from 1 to 2. 1 is the lower limit, 2 is the upper limit. After solving, we got x 3 plus 1 is 4 by 4, and the limit are from 1 to 2. Since 4 is a constant, you can take it out, otherwise you can write like this. Put the value of 2 in x, upper limit, 2 to the power 4 by 4 minus, then lower limit, substitute the value of lower limit in x, to the power 4 by 4, and the answer is 2 to the power 4 is 16 by 4 minus 1 by 4 equals to 16 by 4 is 4 minus 1 by 4 equals to 15 by 4. We won't use plus c. Plus c is only given where the limits are not specified. The answer is Clear? What I did? Integrate x cube dx from 1 to 2. First you have to write that you know the integration of x cube by using the first formula. Add the power by 1 and divide the power by 1 plus 1. Then you got the answer x to the power 4 by 4. Then put the value of the upper limit in x 4 and shift. So 2 to the power 4 by 4 and the lower limit 1 to the power 4 by 4 equals to 16 by 4 minus 1 by 4, and after solving it we get 15 by 4. Hope you understood this example of finite integral. We will try to solve more examples of finite integral and integration. Now one more example. You have to integrate at dt from 0 to t, where a is a constant. Yeah, it is very easy. See, a is a constant, so you can easily take it out and integrate from 0 to t dt. Here 0 and t, 0 is the lower limit, t is the upper limit. So you know the integration of t dt. A integration of t dt, t's power here 1. So t 1 plus 1 is 2 and divided by 1 plus 1 is 2. Clear? And the limit are from 0 to t. Now you have to substitute the limits. So a, you can take out 2 because 2 is a constant. So it is easy for you if you take out the 2. Put the upper limit in this, that is t same as t square, minus put the lower limit in place of t, that is 0 but square. So answer is a by 2 t square. Easy? Now we will do one more example. If the question comes like this. Now let's try one more example. Integrate from 0 to 2 x square plus x minus 1 dx. Clear? We have to integrate the given question. Very easy. Integrate this by using the addition formula by separating it. So integration from 0 to first term x square dx, okay, plus integration from 0 to 2 second term x dx, plus, not plus, minus integration from 0 to 2 1 dx. Okay, now you can easily separate this and do the integration. X square dx, you know, 2 plus 1 by 2 plus 1 is 3 by 3, and from the limit 0 to 2. Any doubt? No. Plus integration of x dx, x का power यहाँ पे 1 है, तो 1 plus 1 divided by 1 plus 1, तो x square by 2 from 0 to 2, minus 1 dx. 1 dx, let it is be 0, x to the power 0. So we remember that integration of dx is only x. We can write it as x from 0 to 2. Clear? Now let us just put the limits. Here 1 by 3 is a constant, so you can take it out and put x cube from 0 to 2 plus 1 by 2 is also constant, x square from 0 to 2 minus x from 0 to 2. Now let's put the limit. 1 by 3 x cube, put the upper limit, 2 cube minus 0 plus 1 by 2, 2 square, 2 is the upper limit, 2 square minus lower limit 0 square minus upper limit 2 minus 0. Clear? This is equals to 1 by 3, 2 cube is 8, so you can directly write it as 8 by 3 and minus 0 is 0, plus 2 square is 4, you can write it as 4 by 2, clear, minus 2 equals to 8 by 3 plus 2 minus 2 is 0, answer is 8 by 3, okay, please write down this. Now we will learn some integration of trigonometric functions. Okay. First one is integration of sine x integration of sin x dx is minus cos x. And second, if integration of sin nx dx, okay, n is a number, is multiplied equals to minus cos x by n. Okay. Now, for example, if you have been given with integrate sin 3x dx, so what you have to do? Here n is 3. Simply, you know the integration of sin x is minus cos x. Write down minus, sorry, this is cos mx. Okay, this is cos minus cos 3x, and later differentiate this 3x with respect to x. This is clear. One more example, sin 5x dx. Simple. Sin 5x is minus cos 5x by 5, minus cos 5x by differentiation of 5x is 5. Clear? This is the integration of sin x dx and sin nx dx, which is equals to minus cos nx by n. Now we will see the trigonometric function of cos. Third formula is integration of cos x dx. This is sin x. Clear? Differentiation of sin x with respect to x is cos x. Integration of cos x dx is sin x. Just reverse process. And if you are given cos nx dx, just like the sine function, it is equals to the differentiation of cos nx dx is sin nx by the integration of cos nx dx is sin nx by differentiation of nx is n. Clear? For example, if you have been given to integrate cos 2x dx, clear? That is equals to the differentiation of cos 2x dx is sin 2x divided by, what is the numerical value? 2. Clear? These are some important trigonometric function, integration of trigonometric function, which will be thoroughly used in physics numericals. Lastly, integration of sec square x dx is tan x. If you have remembered, the differentiation of tan x with respect to dx is sec square x. So integration of sec square x equals to tan x. There are not so many functions which can be integrated. There are only some specified functions are there which can only be integrated. In trigonometry, I have given these formulas only which are important in your physics. Otherwise,